At 3:48 in the afternoon on May 27, 1997, a wall of rotating air settled over a quiet residential development northwest of Jarrell, Texas, and did something tornadoes almost never do. It stood still. Not slowed. Stood still. Because of its exceptionally slow forward speed, it subjected a small subdivision called Double Creek Estates to continuous, violent winds for roughly 3 minutes, grinding across the same handful of properties, while a resident named Scott Beckwith stood near the Jarrell farm supply, lifted his camera, and photographed the huge shape bearing down on him. Minutes later, when state troopers and local volunteers reached those devastated lanes Nowlings, no walls, not even the grass, just brown mud, scraped clean, where dozens of families had been living that same morning. This is the story of how one storm wiped a community off the map, and why the state of Texas has never seen anything quite like it in the decades since. Most people picture a killer storm as a vortex that races across the countryside, chasing vehicles down the highway at highway speeds. One of the most violent twisters in Texas history did the opposite. It barely traveled at all. To understand how that is possible, rewind to the morning of that same day. Central Texas in late May sits under warm, heavy air, and locals know the season brings severe weather. What forecasters watched building on their screens that afternoon was something far more volatile. A cold front pushing down from the north slammed into thick, tropical moisture pooled near the surface, loading the sky like a coiled spring. Convective available potential energy, or CAPE, reached values exceeding 6,500 joules per kilogram, an index of explosive power rarely recorded by meteorologists. The atmosphere was primed for a historic eruption, and warning sun flashed across local television screens. Hidden deep within the data, however, was a subtle interaction between competing air masses that would direct this developing monster toward an unsuspecting target. So how does a storm end up crawling the wrong way and grinding a subdivision into mud? Subscribe to the channel, and stories like this one keep finding their way to you. Here is the meteorological puzzle. Almost every major storm system in Texas travels toward the northeast, pushed along by fast-moving jet stream currents high above the earth. This system behaved entirely differently, drifting south and slightly west as it interacted with a slow-moving boundary line. This specific corridor of the Blackland Prairie features flat, open agricultural fields with very little natural topography to disrupt the rotation of incoming storm systems. Feeding on a rich supply of warm, unstable air, the storm cell intensified while sliding along this thermal boundary, moving directly toward the small communities clustered along Interstate 35. Radar operators at the regional weather station watched the circulation tighten with growing alarm. Then, near the community of Prairie Dell at 3:40 in the afternoon, the first condensation funnel descended from the rotating cloud base. It began as a thin rope, almost delicate, twisting against a black wall of sky. Within minutes, that rope began to swell. It widened, darkened, and descended. And what had looked fragile at touchdown was about to expand into one of the most violent vortex systems the state had ever seen. The structural transition occurred with terrifying speed. In the span of a few minutes, the slender column bloated into a wedge, a churning mass so broad it looked less like a tornado and more like a solid wall of dark cloud pressing down onto the fields. At its maximum size, it spread 3/4 of a mile across, roughly 1,300 yards of rotating fury. Inside that enormous column, velocities reached somewhere between 261 and 318 miles per hour, placing it at the top of the rating scale used by researchers. Trees vanished, fences flattened, and all of this destructive energy was advancing forward at an agonizingly slow pace. Extreme velocity is dangerous under any circumstances, but a vortex that lingers over the same spot is exponentially more destructive. Rather than striking a building once and moving on, the constant battering systematically disintegrates even the most solid construction. That grim reality was about to descend upon Double Creek Estates. At around 3:48, the wedge reached the outer boundary of the subdivision, a cluster of roughly 40 custom-built residences sitting on open land. These were sturdy structures, built with quality brick and wood frames designed to withstand the typical storms of the Texas plains. Families were inside, reacting to the urgent sirens and television broadcasts. Some had gathered in interior hallways and bathrooms, clutching blankets and pillows, following every recommended safety protocol. Others stood by their windows, paralyzed by the sight of the dark, revolving mountain of dust and debris. The system did not sweep through the area in a rapid line. Instead, the core of the vortex settled directly over the properties and slowed to a crawl, moving at a speed equivalent to a casual walk. For the residents trapped beneath its center, the crushing atmospheric force simply remained. This prolonged exposure defies the typical behavior of tornadic events. A standard twister impacts a property and departs within 30 seconds, leaving behind damage from a brief, violent blast. The residences in Double Creek were subjected to an entirely different kind of physics. Because the vortex hovered, it subjected every structure to minutes of continuous, multi-directional force. This acted less like a sudden impact and more like a giant industrial shredder. Every second the vortex remained in place, the mechanical stress on the buildings multiplied. Roofs were stripped away first, exposing interior walls to the full force of the rotating debris. Once the internal pressure and external forces breached the structural shells, the wooden frames shattered. The air currents kept grinding, long after the buildings had been reduced to splinters, pulverizing the remnants into dust. If this detailed account is helping you understand the sheer scale of this event, please take a moment to click the like button. It helps our channel share these important historical records with a wider audience. Send from a distance. The storm column did not resemble a conventional single funnel. It contained multiple smaller vortices spinning rapidly within the main circulation, like secondary gears turning inside a larger machine. Scott Beckwith's photographs captured these features clearly, producing images that startled experienced researchers. In the photographs, the swirling columns aligned in a configuration that resembled a towering, dark silhouette walking across the fields, with distinct limbs and a heavy, central trunk. This haunting visual pattern earned the phenomenon a grim nickname among meteorologists. It was no illusion of the camera. The images documented the complex physical structure of an F5 system, where multiple distinct suction vortices concentrate unimaginable energy within a single localized area. Among the properties in the path of this destruction were families whose names are preserved in the memory of the community. Joan Ego was a beloved teacher at the local elementary school, remembered by generations of local children for her dedication and kindness. On that Tuesday afternoon, she was at home with her daughter, Audrey, and her twin sons, John and Paul. The storm claimed Joan, her husband Larry, and their 3 children together in an instant. The impact of this loss was so deep that the school district later named a new elementary campus in honor of the Ego family, ensuring their legacy of service remains a permanent part of the town. All 27 fatalities recorded during the disaster occurred within this single subdivision, illustrating how tightly concentrated the extreme destruction was. The community later erected a granite monument at the site of the former subdivision, engraved with the names of all 27 victims, serving as a permanent place of remembrance. Only a few residents managed to survive inside the devastation zone. 13-year-old John Reyes sought shelter beneath a heavy wooden bed alongside his grandmother and his cousin, as their residence began to disintegrate. Gripping the fabric tightly, he held on with everything he had. When the cyclonic forces finally loosened their grip, the teenager remained alive, surviving the ordeal with cuts and bruises after being thrown by the intense winds. Tragically, his grandmother and cousin were swept away by the intense draft, leaving him as the sole survivor from his household. This stark outcome illustrates the uter-finality of the storm's core. Inside the path of maximum force, survival was mathematically nearly impossible. Only those situated at the very margins of the vortex had any hope of escaping with their lives. When the cyclone finally drifted away from the devastated area, it left behind a terrain that challenged established scientific understanding of F5 damage. The topsoil was gone. Grass, rich black soil, and dep roots were scraped away to a depth of nearly 18 inches, exposing the limestone bedrock underneath. Sewer pipes and water lines buried beneath the soil were exposed to the low-pressure void of the core, with some being pulled entirely from their underground channels. On the county road border, the asphalt layer itself had been peeled off and scattered in fragments across the fields. Motor vehicles were not merely tossed or rolled. They were shredded into unrecognizable pieces of metal and wrapped around distant trees. Plumbing was ripped directly out of the concrete slabs. The concrete slabs that once supported the residences were swept entirely clean, leaving no trace of the walls or furniture that had stood there hours prior. The destruction was so complete that responders could not identify where individual property lines began or ended. And then, the atmospheric violence ceased. The wedge quickly contracted, narrowing back into a rope-like shape before dissipating into the low clouds. The entire life cycle of the tornado, from its initial touchdown northwest of Jarrell to its final decay, lasted just 13 minutes and covered a path of 5 1/10 miles. For a disaster of such historic magnitude, those figures are surprisingly small. The system did not require a vast track or hours of activity to make history. It only needed to stall over a populated area for a few critical minutes. When silence returned to the valley, it was the absolute quiet of a valley where an entire community had been completely erased. Williamson County Constable Bobby Griffin was among the first law enforcement personnel to arrive at the scene. He and his fellow responders navigated the debris-strewn roads, expecting to search for survivors trapped in damaged structures. Instead, they found an empty field of mud, devoid of any recognizable landmarks to steer by. Street signs, fences, and utility poles had vanished entirely. Search teams spent days walking through the mud, searching for any identifiable personal items. On May 29th, 2 days after the disaster, officials concluded the search operations. The direct financial impact was estimated at $40 million in 1997 values, but the emotional cost of the 27 lives lost was far beyond any physical measure. In the wake of this disaster, forensic engineering teams from Texas Tech University's Wind Science and Engineering Research Center arrived to conduct a detailed analysis of the structural damage. They examined the bare concrete slabs, inspecting the stell anchor bolts that had been bent, sheared, or pulled directly from the concrete. This investigation revealed that the homes in the subdivision were actually poorly constructed, lacking proper structural load paths and steel anchor bolts. As a result, the prolonged duration of the winds allowed lower intensity forces to completely sweep them away. The insights gathered from this study played a critical role in the development of the Enhanced Fujita Scale, which replaced the original Fujita Scale in 2007. By analyzing how the intense, sustained pressures interacted with different building materials, engineers were able to refine wind-resistant construction standards and improve structural safety guidelines across the country. The enduring severity of the Jarrell event remains a benchmark in severe weather history. Since that afternoon in 1997, no tornado in Texas has officially achieved an F5 or EF5 rating. This level of intensity is so rare that the entire United States experienced a 12-year period without a single EF5 tornado, a streak that lasted until June of 2025. That was when the National Weather Service confirmed a top-tier tornado near Enderlin, North Dakota, ending the longest drought of its kind on record. This event immediately prompted meteorologists to review historical data from 1997, as the Jarrell storm remains the baseline for assessing the physical limits of severe weather. Despite decades of radar advancements and improved warning systems, the physical reality of a stationary, high-intensity vortex remains one of the most challenging phenomena in atmospheric science. Today, the Struts of Double Creek Estates have been rebuilt, standing once again as a quiet residential neighborhood. The local school bearing Joan Ego's name continues to serve the community, keeping her memory alive for generations of students who never had the chance to meet her. The memorial in Jarrell stands as a quiet reminder of that afternoon, reminding visitors that nature's most destructive events are not always defined by their forward speed, but by their persistence. In 13 minutes, a single storm redefined our understanding of natural forces, leaving behind a legacy of resilience that continues to shape the community and the science of severe weather today. If this historical record was meaningful to you, please like and subscribe as we continue to document the history of our planet's most powerful weather events.